Hello everyone, my name is Sibusiso, but you can also call me Coach Sbu. Welcome to the Maths Buddies channel. In this video, we're going to be sharing a method or some of the methods you can use to solve probability questions. Now this video, it is a video response that was requested by Tobile. So thank you Tobile for requesting this type of question. And then now here we're going to be working through the probability question. So I hope you take as much notes as you can. Alright, so to anyone who's a new viewer or you're a returning one, if you find yourself with any topic that you're struggling with, please be sure that you can also leave that in the comments so that I can be able to generate a video for yourself. And lastly, don't forget to subscribe so that you won't miss when the video gets uploaded. So without wasting any further time, we're going to go straight into today's video. In this video, we're going to be dealing with probability. Now, one thing about probability is that it is a theoretical question like finance and stats. So this means now whenever you're reading a question, you need to always look for keywords, right? So we're going to start off with the 11.1 and read the information, and then I'm going to share with you what are the keywords that are being thrown there and what does it mean in terms of a probability, right? Now 11.1 goes as follows. Events A and B are mutually exclusive. It is given that probability of B, it is 2 times the probability of A, and the probability of A or B is equals to 0.57. Calculate the probability. Now in this question, the first keyword that they've given you is that they said to you the 2 events are mutually exclusive. So what does mutually exclusive mean? So this means that the elements that are in event A are not elements that are in event B, right? So in other words, this means now if I'm saying element A or event A, it is in the circle. If I'm drawing them in according to a Venn diagram, it will be the circle for event A, and then the event B will be like that. As you can see, they are not intersecting, right? But basically the key word mutually exclusive, what it really means is that what you need to understand is the probability of A and B is going to be 0. So that's basically what they're saying here in terms of the mathematical equation. So what is another thing that they've given us? Another thing that they've given us is the probability of A or B. Now in most of the time you won't see this as a keyword, but this is a keyword because now it tells you that what you need to start with is by writing the original formula or the general equation for probability. And the general equation says the probability of A or B is equals to the probability of A plus the probability of B minus probability of A and B, right? So basically this is what we're going to do, or this is what we're going to use to answer our question. So let's go ahead and start there now. So now here we want to say probability of A or B is going to be equals to probability of A plus probability of B minus probability of A and B. Alright, now what do we see here? We know that the probability of A or B, it is 0.57. So I'm going to substitute that. Now here, probability of B, it is 2 times the probability of A, right? So now if that's the case, then this means now if I want to find the probability of A, I'll just divide the 2 in both sides, and then it will be 1/2 probability of B, right? So now since I need to calculate the probability of B, I'll then replace probability of A with 1/2 probability of B. Then I will say plus probability of B minus, now the probability of A and B, we were told that these events are mutually exclusive, so it means this one, it is automatically 0. Then from here we need to solve like that. So now here we have 1/2 probability of B plus 1, because there's a coefficient 1 here, plus 1 probability of B. So this is the same as saying 1/2x plus 1x. Now this gives us 3/2 probability of B. And then now we're going to cross multiply. So we're going to say 2 times 0.57 is equals to 3 probability of B, and then we're going to divide that by 3 both sides, right? and therefore the probability of B is going to be equals to, take out our calculator, so we're going to say 2 times 0.57, got that, and then we divide this by 3, and then our answer is going to be 0.38, and that is how we get into the first question. Alright, now let's go ahead and look into the second one. Now in the second one, I'm going to first read the instruction, and then from there I'm going to share with you what is it that we're dealing with here. Alright, now here they're saying a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective, right, which means they're not working, right? 2 calculators are randomly selected at random, 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. Alright, let me just read that again so I can understand. 2 calculators are selected at random from the box, right? And then the first one, it is not being replaced before the second one it is selected. Alright, now here, first of all, what is happening is we are given 2 sets of events, right? So the minute you're getting multiple events that are happening under the same thing, this then means now we're going to be doing what we call a tree diagram. Alright, so here, what is it that we're given? First of all, we're told that we have a box of 40 calculators, right? So here, this then means now we know that our initial outcome, or our initial number of calculators before we can even take out one box from the calculator, it is what? It is 40, right? And then we understand that out of that 40 we have 5 that are not working, right? So it means if 5 are not working, then the 35 is probably working, right? Now what gave us the hint that gave us here that we're going to be doing a probability is the next following question statement. So the statement, it was saying 2 calculators are selected at random, right? So we're taking 2 calculators at random from the box. Then the first one, when we take the first one, we not replace it before we take the second one, right? So now in a tree diagram, before you even go to a question, you need to understand what this looks like. So this looks like this. So here we have a box, so I'll put it as a dot here, and then in this box there's 2 things about these calculators. It's either it is defective or it is not defective. So I'm using ND for saying it is not defective and D to say it is defective. Now we know that initially these calculators are 40, so which means the outcome is 40, right? And then now, how many defective calculators do we have there? So it means we have 5. So this means here on the top of this line, I'll say I have 5 out of 40 calculators that are defective. And then here I'm gonna say I have 35 out of 40. Now the question, or the statement, it said that when we take out the first calculator, it will either be defective or non-defective. And then now if we take another calculator, right, we're not going to replace this one, which means now when I'm taking a second calculator, the calculators in the box now, they are 39, right? So now if I take it out, it means here on my denominator I'm expecting 9, both there and even there I'm expecting to have 39 boxes, right? So if the first time it was a defective one, then the second one again is a defective. The first time I was taking a defective, there were 5 of them, and then now I took out the first 5, and then now the second time I'm taking a defective calculator, there is 4 of them. Then now what about the one that was non-defective? So if the first time it was defective, the second time I haven't taken the non-defective one, so it means at that time there were still how many? There were still 35. Now if you notice here, if I add the 4 and the 35, it gives me 39, so it means this is correct. Now if we go into the second event, so the second type, it is when the first one was non-defective. So if I take the second one, it can be a defective one, right? So since the first time I took the non-defective, the second time if I'm taking the defective one, it means I haven't taken defective already, so it means there's still 5 in the box. But then if now the second one that I take, it is a non-defective after the first one was the non-defective, which means at first now they were 35, but then now they're going to be 34. So now this is basically how it would look like in a Venn diagram. Now this then means that if I want to find the defective and the defective, right, if I take the first one and a defective and the second one is a non-defective, then I will just multiply these two to find the probability. And then if I'm taking the first one defective and then the second one non-defective, then I'll multiply this value with this one to get my answer. But if it's a non-defective, then the defective I'll multiply here, and if it's a non-defective, then non-defective I'll multiply there. Alright, so now let's go ahead and look into the first question then. Now the first question, it says, what is the probability that the first calculator chosen is not defective, right? Probability that it is not defective, there it is. So probability that is not defective, it is going to be 35 over 40, right? So if you want to press that in a calculator, you can just go to the calculator and say 35 over 40, and then you're gonna get 0. Okay, let me clear this one out quickly because now it's confusing me. Let's do it again. 35 over 40. All right, 7 over 8, so 0.7, 0.875, right? So it's going to be 0.875. All right, now let's look into the second one. Second one, it says, what is the probability that if two calculators are selected, one calculator is defective and the other is not, right? So now what are we looking for? We're looking for a probability that when we take the first one, it's going to be defective, and then when you take the second one, it is not defective. Now, as you can see in the tree diagram, it becomes very easy now, because now you can see that the first one here is defective, and then the second one, it is non-defective. And by looking at this, only thing I need to do is to just multiply what I got from the tree diagram. So the tree diagram said the one that is defective, it was going to be 5 over 40, because this is the one, and then I'll multiply the non-defective one, which is going to be 35 over 39, and it is that one, and then that's going to be the answer for my question. So 5 over 40. Okay, I guess this needs to be cleared every time, right? All right, so 5 over 40 times 35 over 39, and then it gives us 0.112, so 0.112. all right, let's look at the last question. 11.2.3, the probability, what is the probability that if two calculators are selected, both of them are what? Are defective, right? So if both of them are defective, and then it means now here probability that they're both defective. As you can see in the tree diagram, it is very easy now because we have it all day. So what are we doing? We say 5 over 40 times 4 over 39, and then let's see what we have there. So we say 5 over 40 multiplied by 4 over 39, and then we're getting a 0.123, 0.013, yes, 0.013. all right, so that is basically how we answer this tree diagram type of a question. Again, how we saw that this was a tree diagram, it was because of these two instructions here, right? So the minute you're taking something and then you're not putting it back, but you still want to go back into the same box, it means you have changed what? You have changed the outcome, but then now it means it's going to have a different event out of outcome when you go for the second time. Hence now it needs a tree diagram. All right, now let's go ahead and look into the last question, which is 11.3 type of question. So I'm going to first read, and then we're going to discuss what this one is about, and then yeah, we're going to take it from there, getting some keywords. All right, now here it says four different economic books and 3 different life science books are required to to be placed on a shelf. All right, now this one, the minute we're talking about something that is required to be placed on a shelf, so required to be placed on a shelf, now these are arrangements, right? So now here, first thing that you always do in arrangements is just get the total of how many books are there, right? So first we're saying we know that we have 4 econ, right? And we have 3 life science, so I'll use LSC for life science. But then I know that in total, if I'm asking you how many books are there, these are 7 books. All right, so arrangements, so these are arrangements, so let's say arrangements. Now I'm going to read the question, and in arrangements we always listen to what the arrangement is saying, right? You always listen to restrictions and keywords, right? Now here, let's read the first question. The first question says, if you decide to place any book in any position, so here you see here, that is the keyword, in how many different ways can you arrange these books on the shelf, right? So if you're placing these books in any way or in any position, so this means here there's no restriction. First of all, we need to say no restriction. What is the keyword there? Keywords, it is any book, so let's say keyword was any book and any position, because here we any book, any position, we don't mind where we place the book as long as the books are placed, right? So this, then the minute you get a keyword like this, all you need to do to find the different ways or to find the arrangement, what you need to do is you need to calculate the total amount of the books, and then you put it as 7 factorial, right? Or you put that total and then you say factorial. For example, here we're saying we have 7 books, right? We have 7 books here, and therefore our ways is going to be 7 factorial ways, right? So if you press this in the calculator, 7 factorial is going to be 5,040 ways. It's easy as that. All right, let's look at the second one, 11.3.2. Now 7.3.2, it says if 2 particular groups must be placed next to each other, in how many different ways can you arrange the books on the shelf? All right, now here what is happening here? Here we have what we call a grouping, right? So the grouping, the keyword here is that we need to look at 2 particular books. So it doesn't matter which books are, as the minute you pick your particular, then it means you're good to go, right? 2 particular, and then the one that really gave us that we're talking about the group here, it is next to each other. So the groupings work this way, right? So let me explain how grouping work, right? So if, for example, I say to you, we have 2 particular books, right? So what you do is the minute they are sitting next, or they are arranged or they are placed next to each other, what we do is, number 1, we first calculate the factorial way of the books sitting next to each other, right? So we're saying calculate, right, ways the 2 books, right, placed next to each other. Right, so when we do this, we know that we have 2 books sitting next to each other. So it means because of it is 2 books, now the ways is going to be 2 factorial ways, right? Then after that, number 2, what we're going to do is these 2 books, right, we're going to treat them as if they are just one book, right? So we're going to treat them as if they are a single object, right? So what does this mean? So now here, this means now here we had 2 books earlier, right? And then now what we're going to do is we're going to make them a single object, right? So by taking 2 books and look at them as if we have one object, then this means now we have other 5 books that are remaining, right? And then those books, because of we have grouped these ones, we're gonna also group each book alone, like that, right? So by doing this, it then means now if we look at what we have here, it seems like we have 6 books, right? Because the first 2 books, we always need to keep them together, so we're going to group them as one object or as one book. And then the other books, because of they're already all individually, so we're just gonna make them one group. And then as you can see here, we have 6 objects, or I can say, let me just say 6 objects, right? Then from there, we're gonna calculate the factorial of that of that 6 object. So now 6 objects, when we're calculating a factorial of that, right, it is going to be 6 factorial ways, right? And then after having this, all you got to do now is to understand the arrangement of these books. You're going to say now the arrangement will then be the first 2 factorial, so you're going to say 2 factorial times, and then you're going to say the 6 factorial. Then you're going to press this in your calculator. So let's go ahead and find our calculator. 2 factorial times 6 factorial, then that gives us 1440. So the idea here is, the minute they say anything that has to do with next to each other, count how many of these things are supposed to be next to each other, and then you find the factorial way of that. And then after that, you subtract them from the total that you had earlier, and then you look at them as 1, right? So once you subtract them, you need to first see how many things are left first after you have subtracted the 2 in this case, and we see there were 5, and then you add that group as one thing, which makes them 6, and then there's going to be 6 factorial, and then after that you just multiply the 2 factorials, right? Now let's look at the last question. The last question, it says if all economic books must be placed next to one another, as you can see here, you see what is happening here. We're saying all economic books must be placed to one another, and all life science books must be placed to one another, right? And then now it says, in how many different ways can you arrange the bookshelves? All right, so let's write it here so that we can see the explanation. So remember earlier we had how many economic books? We have 2 econ, right? And then we also had 3 life science, and then we said we had 7 books, right? So now here, to answer this question, what we do is, number 1, we look at the grouping, because now here they said all econ next to each other. That's the keyword, next to each other. So the minute we see next to each other, what we do is next to one another. So what you do is you just calculate how many econ books are there. So we see that we have 4 books there. So we have 4 econ, and therefore that is going to be 4 factorial way, right? And then you want to look at the life science one. So now after doing this, right, after doing this, if we take out 4 out of 7 books, we know that we're left with 3 books now left, yeah? 3 books left. And then now when you do the second one it said all life science next to each other, so having these next to each other, we know that how many life science books we have. We have 3 life science books, and therefore because of we have 3 life science books, it means we're going to have 3 factorial ways. Now after taking this group, how many books do we have now left? We have 0 books left, right? Now what are we going to do? Now these books, after taking these 4 books for econ, I will say eco, and this 3 life science, what we're then going to do for the third time is we're going to group them as one object, right? So if it is one object and then this is also another object, it means now here we see them as two objects or as two groups, right? Now therefore what we're going to do is to calculate the way we can place these two objects. It is going to be 2 factorial, this one, 2 factorial ways. Therefore, to find the arrangement, what we're going to do, we're going to take the 4 factorial we got earlier, multiply by the 3 factorial, and then we multiply by the 2 factorial we just got here, right? So here the third step, let me just explain the third step. So we're saying we treat the group as a single object. I think this one is going to be better like that. Alright, so when you treat them as a single object, it means now we have 2 objects arrangement, and you put that. When you press this in a calculator, 4 factorial, let's see, 4 factorial times 3 factorial times 2 factorial gives you 288. And that is all I got for you today. So if you like the video, please make sure that you like it and share with your friends, and leave in a comment. Tell me what you think about this video, and also don't forget to share with me which topic that you would like me to do, so I can be able to generate the methods for that video. And until next time, stay blessed by the best, and I'll see you on to the next video. Cheers.